Hello and welcome to this presentation. My name is Luca Canali and my talk today is what's new with Spark performance monitoring in Apache Spark 3.0. We will start with some introduction and motivation and a recap of Spark monitoring, and then we'll talk about Spark 3.0 improvements and wrap up with some thoughts. I am a data engineer at CERN. I work on Spark, big data platforms, and database services. CERN is home to the world's largest particle accelerator, the Large Hadron Collider, LHC. The computing power used to process and analyze data produced by LHC experiments at the moment is of the order of 1 million cores and 1 exabyte, and this is expected to grow fast in the coming years. On a smaller scale, CERN and its communities make use of big data technologies, and in particular Apache Spark. We run Spark on Hadoop clusters, and we run Spark on cloud containers using Kubernetes. There are many use cases for Spark at CERN. One that I want to highlight here is in the usage of Spark in our analytics platform. Our users can attach their Jupyter notebooks to Spark clusters on cloud containers or on Hadoop, and also make use of specialized high-energy physics software, and most importantly, connect to the various storage systems used at CERN, the storage systems for the experiments, where it contains experiments data, and also HDFS. Good monitoring data is very important for troubleshooting and also for root cause analysis processes. So the idea is that we want to use monitoring data from Spark, workload monitoring, and Spark architectural knowledge together with application knowledge and information on computing environment, process this and produce insights, and also produce actions to improve the performance of the system. That's why having good performance and monitoring data is very important for us. So before diving into Spark 3.0 features for new feature for monitoring, I want to recap some of the standard features so that we get all on the same page. So the web UI is the first and the main point of access for Spark monitoring data. I gather most of you are already familiar with that. The good news for Spark newbies is that in Spark 3.0, there is a new chapter in documentation that covers all the details. Spark metrics are also available using the REST API. There is an example in this slide. I'll leave the details into the documentation. Developers can attach to Spark monitoring data using the developer API. This will most likely go into Spark listeners. So you will write a custom class that extend the Spark listener. Then you can write methods that react on events and collect data and process data if you want, and then attach this custom listener to the Spark session, either on the fly or using a configuration as shown in this slide. As an example of this, I have a tool called sparkMeasure, but first let's review what the architecture of the Spark task metrics. And the executors will execute tasks and collect the task metrics. And these metrics are sent back to the driver using a Spark listener bus, and typically are sent at the heartbeat every 10 seconds. These metrics are then used by the Spark web UI, and are also used by the Spark history server via the Spark event log file if configured. Then you can use these metrics with your own tools that use the Spark listener interface, and sparkMeasure is such tool. I will show you some example of how this can be used, and then you can have a look at it and use it as an example code for your own instrumentation. So that sparkMeasure is on Maven Central, so you can just use it with ---- packages as shown here. And then after the initialization, you will just start, for example, the stage metrics, which is an aggregation of the stages that sparkMeasure will do for you. And then any workload that you want can be instrumented and with a simple API call as shown in the slide. So sparkMeasure will display the metrics aggregated per stage. So the most basic metric is the elapsed time. This is what you normally get just measuring how much time it takes to run a certain workload. And then there are more detailed metrics that come from the task metrics, in particular the executor runtime. This is the elapsed time over all the executors that have run a certain workload. And then CPU time is the CPU time measured on those tasks. Here we can see the two numbers are almost the same, meaning that this workload was CPU bound, as expected if you look at the query in the previous slide. A more complex workload will have additional metrics, for example, I/O or shuffle metrics that are basically zero in this example. Another instrumentation in Spark is the Spark metrics system. This is less well known, the Spark task metrics system, but it's also very powerful and very useful for monitoring Spark workloads. Various Spark components, including the executor and the driver, can sync metrics directly into one available sync, for example, Graphite, and then these metrics can be picked up, for example, with a Grafana dashboard. The type of metrics that are available for executors in the Spark metrics system that uses the Drop Wizard metrics library for transport are also the task metrics, but there are more. There are, for example, Spark internal metrics like the number of active tasks and metrics related to the interaction with the system, like the amount of CPU usage and the I/O system. To use the Spark metrics system, you can configure it with the metrics properties file or with the several configuration parameters with prefix Spark metrics conf, as displayed in the slide. This, for example, syncs to a Graphite sync. Then you can use InfluxDB, for example, to run the Graphite sync. Most importantly, these metrics then can be picked up into a Grafana dashboard that gives you many information on the performance and the metrics of your Spark workload. This is something that we offer to our users at CERN, and we find them very useful. And for example, one of my favorite metrics is the number of active tasks. That gives you an information on how much parallelism Spark you're using at a given point of time. And so are all the cores that are allocated being used or not? These are the type of questions you can answer. Then you have CPU time, HDFS reads. And most importantly, if you look at the right of this figure, you can see graphs that show the evolution of the metrics over time, so time series. And you can correlate the metrics values with the various stages of your workload, for example, with the SQL ID, the job ID, the stage ID that is running. Let's now dive into new features in Spark 3.0. There are some exciting and very powerful new features in Spark monitoring. The first one that I want to talk about is the memory usage monitoring in Spark 3.0. So the problem we want to solve here is that memory is key for performance of all data engines, and including Apache Spark, but sometimes it's difficult to configure. In particular, many of us have been through troubleshooting Java out of memory errors. These are quite difficult to troubleshoot. Another thing that can happen is that to avoid those errors, we might oversize the amount of memory that we give to the executors, but this may be wastage. And sometimes we want, in shared systems in particular, we want to optimize how memory is used. So to get all these results, one way forward is to measure the amount of memory and see the details of the internals of Spark, how this memory is used. The executor metrics instrumentation in Spark 3.0 does just that. It measures the details of memory usage by memory component and also provides values of peak measurements. Because if you think about it, you get an out of memory error or peak allocation, not on average. And it's also integrated with the Spark metrics system, so these values can be seen as time series. This is how it works through the REST API using the web UI URL plus what you see in the slide here. You can get the metrics per executor. For each executor, you can get, for example, the peak memory metrics. On the right of this slide, you have a list of the metrics that you can get. Some of them come from the S, for example, the process tree metrics, which are optional. And and you typically have them on Linux. Some of them come from the JVM, and some from the internals of Spark, like the unified memory details. This is quite useful if you're now a bit confused by the complexity of this. I think the next slide will help. Here you can see a diagram of the various memories areas that you allocate and you can configure in the executor, in the Spark executor when you run it, in Spark 3.0, and also this is for 2.4. And typically you just set the Spark executor memory to a reasonable size and Spark takes care of the defaults. But you can look at the details and you can, for example, at the unified memory pool, which is a key memory area that Spark allocates, that typically is 60% of what you allocate as executor memory size. And then this is also divided in two parts. That's the storage and execution memory that also can be tuned if need be. Normally the defaults are okay. But with the knowledge of these internals, you can make much more sense of the instrumentation given the executor metrics. What I find very useful, again, is to have dashboards and graphs where I see the metrics as time series, and also I can see the metrics values per executor. So the visualization will give me how the memory usage evolution goes through time. So I can see typically peaks where indeed there can be problems with auto memory errors. And also I can see what's the maximum amount of memory that is used, which is an indication that maybe I can save some memory in the allocation. And I can compare also these metrics with other metrics like CPU, number of active tasks, etc. One feature in Spark 3.0 that I particularly like in monitoring is the possibility of using Spark 3.0 plugins to extend monitoring. Spark 3.0 plugins are executor-provided code, user-provided code that is executed at startup of the executors and the driver. And the plugins also allow to extend the Spark metric systems. As we will see, there is a hook to the metric system that is given to the plugin. The type of problem that these plugins allow you to solve is the monitoring of cloud storage, for example, S3, something that is not done by default by Apache Spark. There is also possibility to use this for improved HDFS monitoring. Monitoring OS metrics, very useful for Spark on Kubernetes, and also all sorts of custom application monitoring. This is how plugins work. So when the executors start, the code in the plugin is executed, and the code is given in the plugin is given a hook to the monitoring. So it can actually look at the external packages that run on top of Apache Spark, and also have a hook for the monitoring. So it can the plugin can add additional instrumentation and put it inside the common metrics syncs together with the other metrics that we've seen in the dashboard before. So Spark plugins provide an API for integrating custom instrumentation with the rest of Spark monitoring. If you want to develop Spark plugins, you have to become familiar with the API as reported here in the slide, on the top of the slide. And you end up writing a class that extends a Spark plugin. And typically you have an executor and also driver plugin if you want, where an init method can be written, and the init method gets a hook to the Spark metrics, and then one can register any metrics that we want. Spark plugins can also be used for other applications. Here we care mostly about extending monitoring. If you want to get started with Spark plugins, you can look at the code reported here in the slide, where I've written some demo plugins and also plugins that we will discuss that are useful for monitoring Cloud I/O and OS. For example, this snippet of code shows you how to use this test package, which I also uploaded to Maven Central, so you can use it in -minus packages. And then you specify the plugin that you want to run. For example, here there are two plugins, Run OS command and Demo Metrics plugin. The Run OS plugin, as the name says, will run a piece of code at the startup of the execution. In terms of useful example, the first one that I want to talk about is how to measure container metrics, so S metrics from Cgroup instrumentation. This is particularly useful for Spark on Kubernetes, which is something that has more and more of adoption also here at CERN in general in the community. Since Spark on Kubernetes runs on Kubernetes and using Cgroups, there is extra instrumentation that comes there, and we can just pick it up with the plugins. By default, Apache Spark only instruments the JVM CPU. So this is how you would run this plugin to measure Cgroup metrics. Again, I'm referring to this package. Well, anyway, you need to send the jars or to put the jars in the container used by Kubernetes that contains the code of the plugin. And then you will have to specify which plugins you want to run. In this case, is the Cgroup metrics plugin. The Cgroups metrics plugin implements the CPU time nanosecond metric. This would give them the CPU time used in the Cgroup, so that would be the JVM CPU, but also other CPU. For example, if you're running Python, then you get that too, which is something that normally you don't have in Spark instrumentation. Then you will have memory details, and also, very interestingly, details about the network usage. We'll focus on that in the next example. So the first line that you can see here starts a container where I packaged InfluxDB and Grafana with example dashboards. So this simplifies the usage, or at least testing of this type of instrumentation. Then the instrumentation is actually pointed to by all these sparkmetrics.conf parameters that you see at the end. While the plugin, again, I'm using the package, Spark plugin package, and the plugin is configured with spark.plugins, and it's called Cgroup metrics. If you do all this, and then you run some test workload, you are able to see many different metrics in the Grafana dashboard. And the one we want to focus here on is the network bytes in. So this is the bytes that are coming into the Cgroup per executor, and then you can see the sum for all the executors that make up the workload. And this would be the number of bytes that we are reading from storage, or bytes that we are reading in for a shuffle operation. Another type of instrumentation you can do using plugins that is not available in the Apache Spark without this additional add-on is instrumenting Cloud Filesystems. For example, S3. Apache Spark by default implements only HDFS and local file system instrumentation. So when we use Cloud Filesystem in Spark, we anyway use the Hadoop API. So these file systems are wrapped into Hadoop compatible file systems, where we have metrics like bytes read, bytes written, read operations, and write operation. So the plugin CloudFS metrics with the additional parameter CloudFS name allows to monitor these metrics for any cloud file system, for example, S3A, GS, or any other. And then from the Grafana dashboard, we will see, for example, the number of bytes read from S3 over time. And the different colors represent the different executors. So we can also drill down on that. And then if we move the mouse in Grafana over the data, we can see the exact values and the time when they were measured. And we can also correlate this with, and it's not shown here, but with the SQL execution ID or job ID or stage ID. Another and last example on these topics is the possibility to measure and instrument custom libraries. So one of the works I did for benchmarking and troubleshooting is to instrument S3A with time instrumentation. So where I have implemented metrics like read time for S3, seek time for S3, and get object metadata time. In the past, when I used this with Spark, I also had to do a custom Spark compilation to get these metrics in. Now I don't need to do that anymore because I just can use a plugin and pick up those metrics with this special plugin called S3A time instrumentation. in general, if you have any libraries that run on top of Apache Spark and you want to get the instrumentation of this library or code into the main Apache Spark instrumentation, plugins are the way to go. I want also to mention improvements in SQL monitoring. So SQL and data frame API is now the main API for Spark usage, by, at least here at CERN, but I guess in the community in general. So it's very nice to see improvements in the monitoring of SQL. So one thing that we have also in terms of documentation, the SQL metrics that instrument how the execution of SQL and data frames happen are also been documented, and we can see them in the SQL tab. For example, when we have shuffle operation, we can see more details than what we had in Spark 2.x. And also we have improved the statistics visualization for the very important whole stage code generation steps, where we can see the metrics better described, and we can find which task and stage have the maximum value of the metrics, and also the code gen ID, which can be useful when you have very complex plans. Something that is newer, very, very interesting, is a new structure stream UI that basically happens as a streaming tab in the web UI, very useful for streaming troubleshooting. And there is experimental support for Prometheus in the REST API. And as I mentioned before, improved documentation as new web UI doc and improved monitoring doc, where you can find most of the details of what I've been discussing so far. Okay, I would like to wrap up with some thoughts on Spark Monitor in the community. So each version of Spark in the last few years have improved the Spark monitoring with more metrics and more features. There is still work to do. So if you're a developer willing to work on this, there is much to do, like sync for InfluxDB and Prometheus, further instrumentation of Spark core system, like IO time, Python instrumentation, etc. And also development and sharing of plugins, like I've shown here. I think there is room for many more of them to instrument libraries, and also getting OS metrics like GPU metrics. I also see that this type of instrumentation, in particular with the dashboard and the Spark metric system, is not so popular at the moment. And also the adoption of tools and methods for systematic troubleshooting and root cause analysis still has a way to go in terms of adoption in the community. So if you're running or are responsible for running platforms inside your organization, is something where you can work on getting more experience on this and sharing with your users. And I also want to mention what I think is a bit of the holy grail of monitoring. So building automated systems that can perform a root cause analysis and in general troubleshooting via monitoring data in an automatic way. I think we'll get there at one point, but this is a very hard problem, and the one who solves it, very great. In Spark 3.1, you will find already quite some improvements in this infrastructure. You will find, for example, a new SQL REST API, and plugins also are getting improved. So there are various GLs that I mentioned here that we can expect next year with Spark 3.1, and some that are still work in progress, and then some work also on Hadoop that is quite interesting, that can then be picked up by Apache Spark in terms of IO instrumentation. In conclusion, I would like to say that monitoring instrumentation improvements are one more reason to upgrade to Apache Spark 3.0. In Spark 3.0, you will find memory monitoring with Executor metrics, which will help you troubleshooting and preventing out of memory errors, but also to size your memory better. Also, Spark plugins are key new features in Spark 3.0, and there you could use it to measure Cloud Filesystems, OS, containers, metrics, build your own custom metrics for your own applications, and there is much more that can be done with this technology. It's quite exciting and is evolving. The web UI is also improved with streaming and Spark SQL monitoring being improved. With this, I would like to thank my colleagues at CERN, the Apache Spark community, and I would like to thank you all for your attention.